Hello, my name is François Protais, and I'm going to present my PhD thesis in computer science, Polycube-dominant meshing. Two aspects on the thesis in the title. First, meshing. Let's put ourselves in the shoes of a Chevrolet engineer who want to study the braking system of their Corvette. The first step will be to generate a discretization, meaning a mesh, which will make it possible to simulate stresses on the brakes pad. This will allow to easily study the performance of new designs. Those meshes can take many forms. Often, the goal is to study a local phenomena, which will be better captured with a locally finer discretization. In the same way, an alignment of the elements with the physical phenomena will improve the accuracy of the simulation method. The mesh I'm showing here, which achieves both qualities, is a structured mesh, composed of quadrilaterals. This is usually obtained from a block decomposition, which will give all of those control to the user. The subject of my PhD thesis was the automatic generation of such structures. This brings us to the second part of the title, the polycubes. The goal of the polycube method is to create block structures. I'm going to illustrate this on this bunny, from which you can already see a polycube, literally several cubes. To generate it, we go through an intermediate step. It consists of straightening the edges of the bunny to obtain a straightened version. This Cartesian representation will simplify the study of possible decomposition. We end up with a whole set of possible decomposition depending on the assignment of the boundaries. The choice will allow us to obtain the polycube. It will represent the combinatoric of the block decomposition. By computing the deformation between the straightened bunny and its polycube, this allows us to obtain the block structure, where each of the blocks is represented by a cube of the polycube. One important thing to add, the first step is usually divided into two parts. First, a labeling, and then a straightening. Performing both at the same time is too difficult of a problem to solve. This is a good illustration of the problems that we face when working with the polycube method. Until now, images have been two-dimensional, but this of course works for volumes, where we have an object which we label, then straighten to extract the polycube from it, and finally we get our block structure, with hexaedras at the end. At the beginning of my PhD, each of those steps was problematic. Our success has been to solve 3 of those 4 problems. Let's start with the last 2 steps. Here, it was necessary to carry out an exhaustive study of the possible assignments, to then find the one that is optimal according to our needs, and finally to construct the deformation associated with the assignment. The real challenge comes from the complicated marriage between the continuous problem of the deformation and the combinatorial aspect of the block structure. We present our solution, robust quantization for polycube maps, published in 2022. This allows us to focus on earlier stages. On those, our second major contributions concern the straightening. The straightening corresponds to a map computation from a domain to another, with added planary constraint on the boundaries. Map computation is a very classic problem in computer graphics. The idea is to look for an injective deformation, minimizing a distortion and respecting our constraints. The injectivity is not easy to capture. It represents a quadratic constraint on all of points in the domain. Since 2013, there have been 15 articles in the journal Translational Graphics which have tried to solve this exact problem. We have proposed a new approach for the free maps in 50 lines of code, which for the first time make it possible to concurrently guarantee that we will be able to compute an injective straightening. That leaves us with the last problematic step, labeling, where the problem is that some labelings will induce a loss of geometry during straightening. This is what we recently presented at the International Meshing Roundtable, concluding that the validity of labeling remains an open problem. On those few results from my PhD thesis, I thank you for your attention.